Video, I will be recording the entire 2015 AP Calculus AB exam free response questions. All right, question number 1 says the rate at which rainwater flows into a drain pipe is modeled by the function r, where r of t equals 20 sine of t squared over 35 cubic feet per hour, where t is measured in hours and t is between 0 and 8. The pipe is partially blocked, allowing water to drain out of the other end of the pipe at a rate modeled by d of t, is negative 0.04 t cubed plus 0.4 t squared plus 0.96 t cubic feet per hour between 0 and 8 again. There are cubic feet of water in the pipe at time t equals 0. So as we've talked about, we always underline this is our initial value. So this is saying that the amount, so I'll call it amount, at time 0 is equal to 30. All right, and A is just going to be the amount coming in minus the amount coming out, right? So for part A, it says how many cubic feet of rainwater flow into the pipe during the 8-hour time interval 0 to 8. So we're only talking about the amount that's coming into the pipe, which is our R of t. So what we're going to do is, since this was in cubic feet per hour, we need to integrate to get cubic feet. So we're going to say from 0 to 8, R of t dt. And I don't waste time writing out the function or anything. I just put it in like that. Now I've already put this into my graphing calculator under y1. All right, so I'm going to integrate y1. So I'm going to do math, 9, vars, y vars, function y1. And I'm going to integrate that from x equals 0 to x equals 8. Or in this case, t equals 0 to 8, right? And I hit enter, and I get 76.570. All right, so that is my answer. All right, what it is what the units are is just in gallons, or not gallons, what am I talking about? Cubic feet. It would make sense that it's gallons if it's water, but that's okay. All right, so part B, is the amount of water in the pipe increasing or decreasing at time t equals 3 hours? Okay, so we need to talk about the r minus d. So we need to figure out what's happening, the rate that it's coming in at time 3, and the rate that it's leaving at time 3. So we need to compare those. So we're finding r of 3 and also d of 3. All right, so when I do that, I go to my calculator, and you can do this a couple different ways. So you could do vars, y vars, function y1, and you can actually do of 3. And then you can do minus, and I actually have the other one in as y vars, function y2. And I can say y2 of 3. And I don't even know if we've actually talked about that in class, that you can do that. It's kind of nice. And you end up getting negative 0.314. Okay, so what we need to decide is, is more water coming in or is more water coming out? And that's what we just did. We saw that it's a negative amount, meaning that more water is leaving than is coming in, right? So the amount of water in the pipe is decreasing. So you could say like R of 3 is bigger than, not bigger, it's smaller, right? Is smaller than D of 3. So the amount of water is decreasing at time t equals 3, which is in hours. All right, and then C, it says at what time between 0 and 8 is the amount of water in the pipe at a minimum? Justify your answer. Okay, so if we're talking about the amount of water in the pipe, okay, it's not totally equal to this r minus d. I really should say it's the integral of r minus d, and then we add on that initial amount, which was 30, right? So I should set that up. I should say, okay, well, for the first t hours, we're going to have our amount that went into the tank, I'll use x's here, minus the amount that left the tank. All right, but I also have that initial amount, which is 30. So I'm going to say plus 30. And all of that equals your amount at time t. Okay, so I'm writing it out very formally. All right, now remember, we've talked about that before. If I'm integrating, let's say a prime to simplify it, from 0 to 30, not 30, t. What we would get would be a of t, really should say x here, a of t minus a of 0, and the a of 0 is the 30. That's why I'm adding 30 to this integral. Okay, it's coming from the fundamental theorem of calculus. All right, it's like saying if you start with 30 and how much have you gained in those first 8 hours, you still had 30 originally in there. Okay, so when I find this, so I'm going to find my a prime of t, which is going to be the derivative of all of this. So if I have the derivative of an integral and then the derivative of a number, I end up getting r of t minus d of t. Okay? So I want to find when that's equal to 0. In other words, where is r of t equal to d of t? And since I have both of those in for y1 and y2, I just go to my calculator and I find their intersection point. So I'm going to make sure my window is from 0 to 8 just so I don't mess myself up and pick a number that's bigger than 8. And I do a graph. And then I find where they intersect each other. All right, now I'm not seeing a lot of this graph. I'm seeing one, I guess. I guess that's good. All right, so I'm going to do second trace. I was going to adjust the window, but I didn't need to, did I? Intersect. And I go right to where my intersection point is and do enter, enter, enter. So I get 3.2716, blah, blah, blah. So I'm going to do second quit. I hit X, and I store it. So I'm storing it as alpha A. And I'm going to write that down. So I have t is equal to 3.27165 something. All right, which I'm going to say let A equal 3.27165 something. So I'm going to store it as my A. All right, and so let's look at the graph again. Okay, were there any other intersection points? And there actually was. It was right here at 0. So if you plug in 0 to both of these functions, right? So sine of 0 we know is 0, and then a polynomial where we don't have a constant term, that's also equal to 0 when you plug in x equals 0. So it was also at time t equals 0. So don't forget that one. And then typically I do a little test. I say, okay, I'm on the interval 0 to 8. I'm thinking about a prime. I have critical values at 0, but also 3.27165, right? And I'm going to test in each interval. So if I test, let's say, 1 into a prime, that's r of t minus d of t. So what is r of 1 minus d of 1? We would need to find that. So I'll pull up my, I'm not going to put this all in again. I'm doing second enter clear until I get that y1 minus y2. So I'm going to plug in 1 for these. So I get a negative amount, all right? But if I do second enter and I plug in like 4, I get a positive amount. So that means that A was going down and then it was going up, so that indeed is a minimum. So we need to justify our answer somehow. So we can do that. So we don't just leave the chart, we have to say what's happening. And we would say something about a prime is less than 0 on 0 to 3.27 whatever, and a prime is greater than 0 on the other part. Therefore, there is a minimum at t equals 3.272 hours. Okay, and that I believe would be enough justification. Now what the AP scoring guide likes to do, and you'll see this from time to time, is they'll say t and then amount at time t, and they actually plug those numbers in. Now, you can tell it's a minimum based on that, right? I don't have to check my endpoints. I don't have to check 0 and 8 because I know that my function was going down and then it was going back up, right? But they like to try these. They like to plug them in. So you might see something like this. So when you plug in 0 into a of t, which was up here, right, you'd have 0 to 0, which gives you 0, and you'd end up getting 30. All right, and then when you plug in 3.272, or a, which you've stored, you would end up getting 27.965, and when you plug in 8, you'd get 48.544. But personally, I don't think that you really need to do that, because as long as you've justified like this, you're good. You've said that there's a minimum, right? You've even checked the endpoints. You know that the endpoints are higher than that is. Now, if you had something where it went back down, then yeah, you should plug in those values and find the endpoints. But I think that was a little bit extra in this case. All right, and then part D, it says the pipe can hold 50 cubic feet of water before overflowing. For time t is greater than 8, water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. Write, but do not solve an equation involving one or more integrals that gives the time w when the pipe will begin to overflow. So again, it has to do with our 30, right? Plus, and it's talking about the time w. So I'm going to, instead of writing t, I'm going to write from 0 to w. And then I'm going to do my r of x minus d of x, or r of t minus d of t. And I want for all of that to equal 50. Okay, that would be perfectly fine. You don't have to subtract the 30 over or anything. You just set it up just like that. So the scoring guide for question 1, you get 2 points. 1 point for the integrand, so the r of t, 1 point for your answer, which is the 76.570. For part B, you get 1 point for considering what r of 3 and d of 3 are, and deciding, well, r of t is smaller than d of 3, so that's going to be your answer with reason, so a point there. Part C, the amount of water between 0 and 8 is 30 plus, we did this, so considering where r of t minus d of t is equal to 0, so we took the derivative of this, set it equal. 1 point for your answer and 1 point for your justification. And then part D, you get 1 point for the integral part, you get 1 point for your entire equation. All right. Number 2, it says let f and g be the functions defined by f of x equals 1 plus x plus e to the x squared minus 2x, and g of x be x to the fourth minus 6.5x squared plus 6x plus 2. Let R and S be the two regions enclosed by the graphs of f and g as shown in the figure above. Find the sum of the areas of R and S. Okay, so we've done lots of area and volume problems, and I've told you that over the last few years, they've gotten a lot harder. And you guys can see this is finding two areas, not just one area. So we have to add them together. All right, so what we're going to do is our f of x, let's see, I have these graphed. Our f of x is our first one, so let's look and see which one that is. It's an e to the x equation. So when I hit graph, you can kind of tell that it's that curve right here. So this is going to be the f of x equation, and then the other one is going to be our g of x equation. All right, so when I find the sum of the areas, I'm going to need to find where they're intersecting. So I'm going to go ahead and graph them as I have both of them in my calculator already. Graph both of those. And I'm going to find their intersection point. Okay, so they have 3 intersection points. 2 of them are already given to us. So we had 0, 2 already, and we had the point 2, 4 already. Do you guys see? 0, 2, and 2, 4. So we need to find this intersection point right in the middle. So I do second trace intersect. I'm way up there. So I'm looking at my y values. I want to get kind of close to 0. All right, there we go. Enter, enter, enter. So I have x equals 1.0328 and y is 2.4011. All right, so I'm going to go back to my main screen. I'm going to hit x, and I'm going to store it as alpha a, and then I'm going to hit y, so alpha y, and I'm going to store it as alpha b. Okay, just so I have both of those. All right, and I'm going to write that I did that on my paper. Now, you also have to write what you did to get that point. What we did is we set f of x equal to g of x, right, to find the intersection points. And when we did that, we got that x intersects at 0, 1.03283 something, and 2. Okay. So we're going to let, and I usually kind of write it here, so 1.032 ... comma 2.4011 ... and I circle A and B. I'm like, okay, I've stored these as A and B. So I'm going to let A equal 1.03283 and B is equal to 2.4011, just in case I need those values, which I know I need the A, but I may not need the B. But sometimes you might need it for one of the volume ones. All right, so if I'm finding the sum of the areas of region R, I'm going to say my area, total area. So for R, it's going to be top minus bottom, so it's g of x, the red line, minus f of x. And that goes from 0 to A. And then the other one is from A to 2, and that would be f of x minus g of x. And I put this into my calculator, and I do math 9. And I can just say, okay, I need my y vars. So vars, y vars function, I believe it was y2 first, minus vars, y vars function, y1. And my x goes from 0 to A, and I can get that answer. And then I could add it, you can actually do this all together, to math 9, vars, y vars function, now the f of x is on top, minus vars, y vars function, y2. And now that's going to go from A to 2. And we put it all in together, and we get an answer of oops, maybe not. I thought it was going to be 2.004. I did this earlier. So did I mess it up somewhere? So let's see, g of x minus f of x from 0 to A, and then A to 2. Oh, you know what? I'm using y1 and y2, and it's not y1 and y2. It is y3 and y4. So I forgot I had the first question in there as well. So we're going to do y4 minus vars, y vars function, y3, and then the same thing here, but y3 minus y4. All right. So yeah, 2.004 is the answer. And you could find each one individually. I actually found each one individually before, and I had like 0.9974 plus 1.0069. So you can do that if you want, or you can do it all together like I did. All right, and then region S is the base of a solid whose cross-sections perpendicular to the x-axis are squares. Okay, so let's kind of clear this out a little bit. All right, so I have cross-sections perpendicular to the x-axis. So I'm making my chops like this, and off of each of these chops I have a square shape. So I have this side and I have another side, okay? So the side ends up being the top curve, which was our f of x, minus the bottom curve, which was our g of x. So my side, and you can write that out, side, or s, is equal to f of x minus g of x. So that's one side of the square. So when I'm finding a volume, I'm always integrating an area. So I'm integrating the area of a square, which is going to be side squared. And I'm doing that from my a value to my 2. Okay, so I went ahead and found that, and it ends up being 1.283. So you can do math 9, you can put all that in. You do get 1.283. And then the last part, it says, let h be the vertical distance between the graphs of f and g in region S. Well, we already did that. That's f of x minus g of x. Find the rate at which h changes. So we're writing h of x is equal to the top minus the bottom. So the rate, that means h prime, is going to be f prime of x minus g prime of x. And we want to find it when x is equal to 1.8. All right, so we want to find h prime of 1.8, and it's going to end up being f prime of 1.8 minus g prime of 1.8. And if you look at your functions, f of x and g of x, not really that fun to take the derivative of. You can. It's not terrible. But if we have our calculator, I would just use my calculator, right? So I'm going to go to my main screen, and I'm going to do math 8, which is n deriv. And I'm going to find the derivative of f at 1.8. So I'm going to do vars y vars function, and like I said, this was in for y3. So I'm taking the derivative of y3 at x equals 1.8. Okay, and then I could do minus, and I could do my other one as well. So math 8 n deriv vars y vars function y4, and again evaluated at x equals 1.8, right? So I put all of that in. Now your calculator might actually look like, when you're putting in n deriv, it might look like d, and you'd put in an x, and then it's going to say, you know, something evaluated at x equals. So you're going to put in y3 like I had at x equals 1.8 to get that. So it might look a little bit different when you're doing this, but regardless, you should get the same answer, which is negative 3.812. Okay, so the last thing we'll look at is the scoring for question number 1. So the scoring, it says the graphs of y and g intersect in the first quadrants at the points 0, 2, 2, 4, and also a, comma, b. All right, did we actually need to list the points? We did not. Okay, so the area ends up being, so you get 1 point for your limits, 0 to a and a to 2. You get 2 points for the integrands, which are g of x minus f of x and f of x minus g of x. And you get 1 point for your answer, which is 2.004. For part B, you get 1 point for your integrand, which is f of x minus g of x squared. You get 1 point for the answer. You get, for part C, 1 point for considering that h prime is f prime of x minus g of prime of x, I guess. And then 1 point for your answer. Question number 3 says, Johanna jogs along a straight path. Between 0 and 40 minutes, Johanna's velocity is given by the differentiable function v. Selected values of v of t, where t is measured in minutes and v of t is measured in meters per minute, are given in the table above. Okay, so we have the velocity at various points. Okay, and part A says use the data in the table to estimate the value of v prime, so the derivative, of 16. So we have no function that we can actually take the derivative of. So what we do is we use these 2 points. So we're going to find v of 20 minus v of 12 all over 20 minus 12, which is the average rate of change between 12 and 20. And so when we do that, we end up getting 240 minus 200 over 8. So 40 over 8 ends up being 5. And our units, since the numerator was in meters per minute and the denominator is in minutes, it's meters per minute, or meters per minute squared. All right, always write the units. A lot of times you get a point just for the units. All right, part B says using correct units, explain the meaning of the definite integral, the integral from 0 to 40 of the absolute value of v of t dt. So hopefully we've talked about this enough in class. If you have the absolute value of v of t that you're integrating, that ends up being the distance, right? So our distance is always equal to the integral of the absolute value of v of t dt. If I wanted displacement, like how much it moved from its starting position, final minus initial, it would just be the integral of v of t. All right, so we're going from 0 to 40, and we're going to approximate it using a right Riemann sum with 4 subintervals from the table. Okay, so a lot of times, like I said, it helps if you sketch this out. So if you sketch out like 0, 0, 12, 200, I mean, it doesn't have to be perfect, 20, 240, 24, negative 220, and so it must be moving backwards at that point, and then 40, 150. So if you do that, it kind of helps when you think about what a right Riemann sum is. So a right sum would involve right endpoints. So we would take this endpoint here, and we would go straight over to create our first rectangle. Okay, so we go to the left. We use the right side to get the height. So this one and straight over, right? This one and straight over. So it's a little tricky because now we have a negative one. And then this one and straight over. Okay, so that would be our right Riemann sum. Now if you have the chart, you guys should be pretty familiar with this. You shouldn't have to draw it out. Sometimes it helps. But we would use 1, 2, 3, 4, and we wouldn't use this one. Our widths of our rectangle would be 12. The next one would be 8. The next one would be 4. And the last one would be 16. Okay? So the 12 corresponds with the 200. The 8 corresponds with the 240, and so on. So as you can see, we have a 12 by 200 rectangle. That's what I'm saying there. And then we have an 8 by 240. And we have a 4 by negative 220. And we have a 16 by 150. So this is a question number 3 problem. So this is a non-calculator question. So it's kind of a lot of computing that you have to do. But you end up getting, let's see, 2400 plus 1920 minus, oh, you know what? I totally forgot. I need to consider that these are all going to be in absolute values. So this one, right, if it's a distance, right, we're going to get positive, so it's going to be plus 880, and then plus 2400. So let's see, 4800 plus 880, so 7600 meters. Since we're integrating something that's meters per minute, we're going to end up getting meters in the end. Okay, so basically this rectangle that was below now goes above and has a height of 220 because we were taking the absolute value. All right, and then C. Bob is riding his bicycle along the same path. So between 0 and 10 minutes, Bob's velocity is modeled by b of t equals t cubed minus 6t squared plus 300, where t is measured in minutes and b of t is measured in meters per minute. Find Bob's acceleration at time t equal 5. Okay, so this is a pretty easy question. If I want to get the acceleration, I just take the derivative, right? So it's going to equal 3t squared minus 12t, and that's it. And then we're going to plug in acceleration at time 5. I don't know what I was looking at. Acceleration at time 5. So we're going to get 3 times 25 minus 60. So 75 minus 60 is 15. Okay, and it's an acceleration, so it's not going to be meters per minute like the velocity. It's going to be meters per minute squared. All right, I realized as I was doing that, I forgot to say, using correct units, explain the meaning of the definite integral. Okay, so you would need to say somewhere in part B that this integral is the total distance that Johanna jogs, I guess, travels. Oops, not jobs, jogs. In the first 40 minutes, or on the time interval 0 to 40 minutes or whatever. I'm just going to say in the first 40 minutes. Okay, a little messy there. All right, let's give myself some more room. So it says part D, based on the model B from part C, find Bob's average velocity. Okay, so average velocity you could do 2 different ways. You could do the average rate of change of the position, but we don't have the position function, so we can't do it that way. Or average velocity could be the average value for the velocity function, and we do have the velocity function. So we're going to set it up as 1 over b minus a, right? 1 over 10 minus 0, the integral from 0 to 10. And then we're going to put in the velocity function, which was our b of t. And you can write it like that to begin with. But then we're going to integrate the t cubed minus 6t squared plus 300. This is a non-calculator question, so we have to do that all out. It takes a little bit. So I get 1/4 t to the 4th minus 2t cubed plus 300t. And luckily we have nice numbers 0 to 10. So we're going to have 1 over 10 out front. And then we're going to have, let's see, 1/4, 10 to the 4 is going to be 10,000. minus 2 times 10 to the 3 is going to be 1,000 plus 3,000. That's the first part, and luckily the whole second part is 0. So if you multiply this 1/10 then, you get rid of your zeros on the end of each one. Maybe you could do that. So you have a fourth of 1,000 is 250 minus 200 plus 300. So we get, let's see, 50 plus 300, so 350. And this is an average velocity, so it is in meters per minute. All right, so that would be the end of that question. All right, so let's see how we did and check our points. So for part A, you get 1 point for the approximation of 5 meters per minute squared. It doesn't say that you had to have the right units, so if you just had 5, you're fine. For part B, you get 1 point for the explanation. That's what I remembered at the last second. Oh yeah, I forgot to do that. So that it's the total distance that she jogs over the first 40 minutes. 1 point for your right Riemann sum. So getting the 7,600 meters. I believe if you leave it here, so if you're in a rush, if you leave it there, they will still give you the points. So if you're freaking out and you're like, oh, I'm never going to finish this test, just leave that, go back and do it later. And then 1 point for the approximation. So yeah, maybe that's the 7,600 meters. All right, number 2, you get 1 point for using b prime of t, so knowing that the acceleration was b prime, and 1 point for plugging in to get the answer, which is 15. And then the last part was 3 points, 1 point for the integral, 1 point for the antiderivative, and 1 point for your total answer. Okay, question number 4. So it says, consider the differential equation. We like the differential equation problems. So it says, on the axis provided, sketch a slope field for the differential equation at the 6 points indicated. So I actually cut that off of mine. So the 6 points were at 0, -1, 1, -1, 0, 1, 1, 1, 0, 2, and 1, 2. Those were the 6 points that we need to find the slope at. Okay, so what we're going to do for part A is we're just going to plug in those points. So we have dy over dx equals 2x minus y. Okay, and you can do a table if you want. I think a table sometimes takes a lot of time. It's not really like super necessary. So for this first point down here at 0, -1, we're going to plug in 0 for x and -1 for y. So we end up getting 1. So our slope here has to look like 1. So we want it to point towards here, right? So up 1 over 1. So it's going to be just like that. So if I did the other ones that have 0 for x, we would have -1 here, and we'd have -2 here. Okay, so just make it even more steep. All right, and then if I plug in 1 for my x, I'm going to have 2 times 1, and let's say I'm doing the point on the bottom, so I'm going to have minus a -1. So I get 2 plus 1, which is 3. So it's going to be a pretty steep slope of 3. And then the next one, I'm going to have 2 times 1 minus 1. So I get 1. And then the next one is going to be 2 times 1 minus 2. So it's going to be a slope of 0. Okay, so that's what your slope field should look like for that one. All right, part B says find the second derivative in terms of x and y. Determine the concavity of all solution curves for the given differential equation in quadrant 2. Give a reason for your answer. Okay, so we're going to take the second derivative. We're going to take it implicitly, so I'm going to have the derivative of 2x is 2. The derivative of y is 1, but it's times dy over dx. So we get 2 minus 1 times 2x minus y, right? That's what dy over dx was equal to. So once we have that, we're going to have 2 minus 2x plus y, like that. And we want to think about points that are in quadrant 2. So quadrant 2 points, let's see, have negative x values and positive y values, right? So if you have a negative x value and a positive y value, and you're looking at this derivative, we'd have a negative here, and we'd have a positive here. So let's think about it. If I pick any negative number and a positive for the y, I'm going to have 2 minus 2 times some kind of negative. Well, that's going to make it even more positive, right? Because you're going to have negative 2 times a negative is going to be positive. And then plus another positive number. So what they're asking is it concave up or concave down? So quadrant 2 points have x is less than 0 and y is greater than 0. So that means d2y over dx squared is always positive. So all solution curves will be concave up in quadrant 2. Okay, so that's what it's asking. Will it be up or will it be down? All right, and then part C says let y equals f of x be the particular solution to the differential equation, we've seen this a million times, with the initial condition of f of 2 equals 3. Does f have a relative min, a relative max, or neither at x equals 2? Justify your answer. Okay, so if you're trying to find the solution to the differential equation, you actually run into some problems, right? Because it's not separable, right? We have dy over dx is equal to 2x minus y. So even though we've seen this lots and lots of times, it's kind of misleading. And I remember my students on the AP test, from the AP test last year, after the test, a couple days later, they were saying, oh man, there was this one that was a differential equation, and I tried to solve it, and I just couldn't. And when you looked at the scoring of the AP test, a lot of students all over the nation missed this problem because they had been so trained to do these to find the solution, but it never says find. It doesn't say find the particular solution. It says let this be the particular solution. Okay, so it's a little bit hard. So if we're trying to decide if it has a relative min, a relative max, or neither, I think what we're going to do is use the second derivative test, and that's probably why they had you find the second derivative in part B, right? So we're going to use this point, which is 2, 3, and we're going to plug it in to here. So sometimes you write x equals 2, y equals 3, or you could write it as I don't know, xy is equal to 2, 3. Doesn't matter how you write it. So we end up getting 2 times 2 minus 3. We get 1. Okay, so that means that we have a slope of 1. Would we have a slope of 1 at a minimum or a maximum? No, our slope would be either 0 or undefined, right? So this means that, therefore, there is neither a relative max or min at the point 2, 3 on the graph of f. Okay, because we would need that slope to be either 0 or undefined. So let's say it was 0. If it's 0, then we look at our second derivative. We plug in that point into the second derivative. And then we want to know if it's positive or negative, right? So if the second derivative is positive, that would mean that you have concave up and you have a slope of 0. That would be a minimum. But if the second derivative is negative, you have concave down and a slope of 0. That would be a maximum. So that's what we call the second derivative test. So it's kind of leading us to using that. And then part D, so it says let me go back up there. Find the values of the constants m and b for which y equals mx plus b is a solution to the differential equation. So it's saying you can't find the solution right now because it's not separable. There are ways in regular differential equation classes in college and so on to do that, but we don't know how to do it. We've only dealt with separable ones in AP Calc. So we're saying, well, what if y equals mx plus b was a solution? Okay, if y equals mx plus b is a solution, that means that when we take the derivative, our derivative ends up just being m, right? Like the derivative of mx plus b is just whatever m is. So that means that our 2x minus y that we had before has to equal m. So that's an equation that has x and y. We're going to have to solve for m using it. But it's a little bit weird because y is also equal to mx plus b. So what we do is we substitute it in there. And I think we've done one of these before in class, and they're just kind of strange. So we're trying to get everything so that we only have two variables. We're trying to figure out m and b and so on. So that's all going to equal m. So 2x minus mx minus b is equal to m. All right, and what we're going to do is we're going to say, well, if this is going to be a solution to the differential equation, let's see. Well, maybe I should get everything on one side. What's the best way of doing it? Let's get everything on one side. So I have 2x minus mx minus b minus m. And I'm going to talk about my x terms, and I'm going to talk about my non-x terms. Okay, this is all equal to 0 now. Okay, we want our x terms to go away. We want it to be equal 0. All right, so we want 2x minus mx to equal 0. We don't want any x terms. So that means that m has to be 2. And then the negative b minus m also has to go away. It has to be 0. So not only do the x's, we needed like 5x minus 5x plus 2 minus 2. We needed something like that, right? Where the x terms canceled and the y terms cancel. Or not y terms, the constant terms. So we would end up getting negative b equals m. So that's 2. So negative b equals 2. So b equals negative 2. So yes, I believe your solution should be m is equal to 2, and then b is equal to negative 2, which is, like I said, a really tough question. And a lot of students across the nation did not do well on this question last year. So when that happens, that adjusts the scores for everybody. So, that's always good when, even if you don't understand how to do it, you can still get a 5 because other people had trouble with it as well. All right, so as for our scoring, for part A, you get 1 point for having the slopes where x is equal to 0, so these 3. And then 1 point for the slopes where x is equal to 1. For part B, you get 1 point for having d2y over dx squared, so the second derivative, as 2 minus 2x plus y. And then 1 point for knowing that it's concave up with the reason. And then part C, you get 1 point for finding dy over dx at 2, 3. And then 1 point for your conclusion with justification, so saying, well, there's not a max or a min because the slope isn't equal to 0 or it's not undefined, right? And then D, you get 1 point for finding the derivative of mx plus b is m, 1 point for setting 2x minus y equal to m, and then 1 point for your answer. All right, and our last question, well, not last question, question number 5. It says the figure above shows the graph of f prime, the derivative of a twice differentiable function f, on the interval -3 to 4. Okay, so we've done several of these in class. I think a lot of times you guys don't like these ones, but we've done them. All right, the graph of f prime has horizontal tangents at -1, 1, and 3. The areas of the regions bounded by the x-axis in the graph of f prime are 9 and 12 respectively. So here and here we have an area of 9 and we have an area of 12. So part A says find all x coordinates at which f has a relative maximum. Give a reason for your answer. So although they don't grade the sign charts, what I always do is I would draw the sign chart, right? So we're talking about f prime. It's bounded on the interval -3 to 4, and it's closed, right? Closed brackets between -3 and 4. And we said that we want to know where f prime equals 0. So f prime equals 0 here, here, and here. It's where it's crossing the x-axis. So at -2, 1, and 4. So now we want to talk about where f prime is positive and where it's negative. So it's above the axis from -3 to -2. And then our curve, f prime, is below the axis from -2 to 1. And then it's above the axis again. No, it's below the axis again from 1 and 4. Okay, so what does this mean about our curve of f? It means that f is increasing, decreasing, tapers off to a slope of 0, and then decreases again. So a little rough sketch would be something like this. Up, down, tapers off to a slope of 0, and then goes down again. And it's bounded on these endpoints. So it would have a relative maximum only here. Okay, so at -2. So our justification for that is always that f prime changes from positive to negative when you talk about a relative maximum. So f has a relative maximum at the x value of -2 because f prime changes from positive, I'll write it out, to negative at x equals -2, okay? Now, if you wanted to be super sure that they are counting this as a correct answer, what I would probably say is something about how f prime of x is equal to 0 at -2, 1, and 4. And then you could say like f prime is greater than 0 on -3 to -2. F prime is less than 0 on -2 to 1 and 1 to 4. So just make sure that all of that information from your sign chart is shown. All right, and then part B, on what open intervals contained in -3 to 4 is the graph of f both concave down and decreasing? Give a reason for your answer. Okay, so if I'm talking about concave down, I want for f double prime to be less than 0. So this is going to happen where your graph of f prime is decreasing. So going back up to our graph of f prime, we're decreasing right here, and we're decreasing right here. So I would write that. So f double prime is less than 0 on -3 to -1, and also 1 to 3, because f prime, the graph of f prime, is decreasing. All right, so that's where it's going to be concave down. And then where is it decreasing? F prime is less than 0 on, so that goes back to our sign chart above, -2 to 1 and 1 to 4. And why is that? Because this graph that we have of f prime, so f prime is below the axis, or f prime is negative. I mean, that's kind of what I said over here, but that's okay. It has negative y values there. All right, so we need to figure out where both of these are happening. So where are they overlapping? So it's a little bit hard. If you need to like line up your sign charts, sometimes that helps. Like that f prime one we had above was positive, negative, negative. And then the one that we're talking about for f double prime, so we said from -3 to -1, so a little bit further. And then from -1 to 1, it's increasing. And then from 1 to 3, we're decreasing again. And then 3 to 4, we're increasing. Okay, so we're decreasing, decreasing, concave down in these spots. So we want to know where they overlap. So therefore, f is concave down and decreasing on 2 intervals. It's going to be from just this little bitty one right here, from -2 to -1, and also from 1 to 3. So like from here to here. All right. In part C, find the x coordinates of all points of inflection for the graph of f. Give a reason for your answer. So points of inflection, remember the justification, I'm sure you guys know, I've said this like a broken record, is that f double prime changes sign. So f double prime changes sign. You can see from that sign chart I just did in part B, it changes sign at -1 and also 1 and also 3, right? It goes from negative to positive, then it goes from positive to negative, and then it goes from negative to positive. So there are actually 3 different places where that's happening. All right, so F, so part C, f has points of inflection. Oops, I almost said points on inflection, points of inflection at x equals -1, 1, and 3 because f double prime changes sign. And that's all you need to say. Okay, now you could be more specific. I think the scoring guidelines, when I looked at them earlier, they had something saying it switches from negative to positive for -1 and 3, but it changes from positive to negative at 1. If you just say f double prime changes sign, you will definitely get your points. All right, and then part D. So it says, given that f of 1 is equal to 3, write an expression for f of x that involves an integral. Find f of 4 and f of -2. All right, so if I'm trying to write an expression that involves an integral, and I know f of 1 is equal to 3, then what I would do is I would say, well, f of x is going to be, your starting position, which is 3, plus how much you gain from 1 to that certain x value using your f prime of t graph. Okay, it's the fundamental theorem of calculus. It looks a little funny, right? You guys know that when you write this, if you integrate it, you get f of x minus f of 1, right? That's what this is, f of x, and then this is f of 1. So see how you could subtract that f of 3 over and you would get exactly the same thing. Or not the f of 3, the 3 value over. All right, so this is called an accumulation function. So we have this. So we want to find f of 4 and f of -2. So f of 4 is going to be 3, and then the integral from 1 to 4 of f prime of t dt. So this is where these areas that they gave us come into play. So they said the area of the first one was 9, the area of the second one was 12. So if I'm adding in the integral from 1 to 4, that's right here. But that's a negative amount. It's below the axis. So what we would get is 3 minus that 12. So your answer would be -9. And then f of -2 is going to be 3 plus the integral from 1 to -2 of f prime of t dt. And that should look a little funny to you. We don't like writing 1 to -2, so I'm going to flip it and do -2 to 1. And when I do that, I gain a negative. So that -2 to 1 is this portion, which was 9. So I'm going to get 3 plus a negative, well, it's kind of tricky because it's minus, right, this was a minus. And then that whole integral here is -9. So minus a -9, so you should get 12 for that one. All right, so our scoring guidelines. For part A, you get 1 point for identifying x equals -2 and 1 point for your answer with reason. Part B, you get 1 point for your intervals, -2 to -1 and 1 to 3, and then 1 point for your reason. Part C, you get 2 points for identifying that points of inflection occur at -1, 1, and 3, and 1 point for your reason, which was f double prime changes sign. And like I said, they broke it up into f prime changes from decreasing to increasing for 2 of the points and increasing to decreasing. You can do that, or you can just write f double prime changes sign. And then D, you get 1 point for your integrand. So probably this whole part here, not just the f prime of x. 1 point for an expression for all of f of x, and 1 point for finding both f of 2 and f of -2. All right, and then the last question for the 2015 exam. It says, consider the curve given by the equation y cubed minus x cubed equals 2. It can be shown that the derivative dy over dx is y over 3y squared minus 2x. So a lot of times part A will say, verify that dy over dx is y over 3y squared minus x. And we always like those problems because, it's an easy point. You know that it's going to equal that. You just have to get there. But now they gave it to you. So part A says, write an equation for the line tangent. So we need a point and we need the slope. At the point, -1, 1. So we have our point. So our point is -1, 1. The slope is going to be plugging into our dy over dx. So dy over dx is y over 3y squared minus x. So if I evaluate it at this point, I'm going to have 1 over 3 times 1 squared is 1 minus a -1. So I get 1 over 3 plus 1 So I get 1/4. So putting it together, I have y minus y1 equals m times x minus x1. So I have this. Okay, you can simplify if you'd like, or you can just leave it like that. All right, part B. So find the coordinates of all points on the curve at which the line tangent to the curve at that point is vertical. So our tangent line is going to be vertical. If your tangent line is vertical, you want dy over dx to equal undefined. Okay, so what we're going to do is we're going to look at our point, and we're going to think about where our denominator is equal to 0, right? That's what's going to make it undefined. Okay, and this is a little bit tricky. It ends up being a system of equations. So we end up getting that 3y squared is equal to x. So this is one equation that has x and y. We need another equation that has x and y. Well, these are all points on the curve, y cubed minus xy plus equals 2, right? So we have another equation. We have, oops, I don't know why I wrote x cubed. We have y cubed minus xy equals 2. So we're going to take this equation and we're going to substitute in. So this was equation number 1, this is equation number 2. We're going to substitute it in. So we have y cubed minus 3y squared times y equals 2. We replace that x with 3y squared, and we solve it. So we have y cubed minus 3y cubed equals 2. So we get negative 2y cubed equals 2. So y cubed equals negative 1, so y is negative 1. And it's asking for the points. It's saying find the coordinates of all of the points on the curve at which the tangent line is vertical. So now that we have y equals 1, we go back into any equation, or y equals negative 1, and plug it in. So let's go back into our 3y squared equals x. So we have 3 times negative 1 squared equals x. So we get 3 equals x. So this means that our tangent line is vertical at the point, it's only one point, sometimes it's more than one because the pluses or minuses, so be careful, at the point 3, negative 1. All right, then part C, it says evaluate the second derivative. So if we have dy over dx equals y over 3y squared minus x, and we try to find the second derivative, we're going to do the quotient rule. So we have low, in the bottom, d high is 1 dy over dx, minus high, d low, again dy over dx, minus 1, all over the square of what's below. So we get this. And now we are evaluating this at the point negative 1, 1. So we're going to plug in all those values, right? So it's a little bit messy. Do we know what the dy over dx is at negative 1, 1? Sure, we found it up above, right? So let's go back up. Dy over dx at negative 1, 1 was 1/4. All right, so we're going to go down here. And everywhere we have a dy over dx, that's going to be replaced with 1/4. And then the x's and y's, x is replaced with negative 1 and y is replaced with 1. So I'm going to have 3 minus a negative 1 plus 1 times 1/4 minus 1 times 6 times 1/4 minus 1 all over 3 minus a negative 1, so plus 1 squared. So we get 4 times 1/4, that's nice, we get 1, minus, let's see, 3 over 2 minus 1, right? 6 over 4 minus 1 is 3 over 2 minus 1, so 1/2. All over 4 squared is 16, so we get 1/2 divided by 16, which is 1/2 times 1 over 16, so your answer should be 1 over 32. So the second derivative ends up being 1 over 32 there. All right, so we're scoring for this problem. For part A, you get 1 point for your slope equals 1/4, 1 point for your equation of your tangent line. Remember, you do not have to simplify, so I would leave it as y minus 1 equals 1/4 times x plus 1. The only time I really simplify is if the second part of the question asks for an approximation, like a linear approximation at a certain value. Part B. So 1 point for setting 3y squared minus x equals 0, 1 point for getting an equation in one variable, so doing the substitution step, and 1 point for finding your coordinates 3, -1. All right, part C, 2 points for implicit differentiation. That's pretty tricky. They're looking for things like the dy over dx, right? 1 point for your substitution for dy over dx. So knowing that you had 1/4 that you're going to plug in there, and then 1 point for your final answer of 1 over 32. All right, so that's the end of the 2015 test.